Hey guys, we're just going to do a few problems here that people had asked for. I'll start with number 49. A recent census at a major university revealed that 60% of students mainly used Macs. The rest mainly used PCs. So you can see I already started my notes. Probably they use a Mac as 0.60, PC is the rest, which is 0.40, right? At the time of the census, 67% of the school students were undergraduates. The rest were graduates. So I said probability being U, which is undergraduate, is 0.67, and then the rest is 1 minus 0.67 is 0.33. All right, in the census, 23% of the respondents were grad students, and they used a Mac as their main computer. So that's why right here, probability of grad and Mac right there, intersection, is 0.23. Suppose we select a student at random from among those who were part of the census. Define events G as is a grad student and M as primarily uses a Mac. Find the probability of having a grad student or using a Mac. That's P of G union M. That the student either is a grad student or uses a Mac. Interpret this value in context. No problem. So the probability of G union M. Now you could do a Venn diagram, and I'm going to show that for part B actually, but for this part right here, we know this is non-mutually exclusive, right? Because we have an overlapping situation right here. That's that they are a grad student and they use a Mac. So we're going to say that's going to be the probability that they're a grad student plus the probability that they use a Mac minus the probability that they use that they're a grad student and use a Mac, because we would count those people twice. We would count them here and for there, so we have to subtract one, right? So the grad student is right here, 0.33. Mac is right there, 0.60, right? So we're going to say right here, 0.33 plus 0.60, and we'll subtract the people that use both, minus 0.23 right there. All right, so that's going to end up being 0.70. Now it says to interpret this in context, so we're going to go ahead and say, in this case right here, over many large random samples of students that have over many large random samples of students in this major university, there is about 70% of them will be a grad student or use a Mac. Okay, so we're saying over many large random samples of students at this major university, about 70% of them will be a grad student or use a Mac. Okay. Part B. Let's see. What's the probability that it says right here, consider the event that the randomly selected student is an undergraduate student and primarily uses a PC. Write this event in symbolic form and use its probability. So an undergraduate and they primarily use a PC. How can we get that? So undergraduate is going to be grad complement, and that they primarily use a PC, that's going to be Mac complement, right? All right, so let's see here. So what we have, let's look at a Venn diagram, and then we can fit whatever is left over right here, we can figure out what that's going to be, right here, it's going to be an undergraduate who uses a PC. So that's going to be grad complement and Mac complement, right? So grad, we already said, is right here, 0.33. Mac is 0.60. Remember, start in the middle first. That's 0.23. All right, so if grad is in total 0.33, that means this leftover is going to be 0.10. And if Mac in total is 0.60, we know that 0.60 minus 0.23 is going to be 0.37. So there we go. All right, so what do we have left over? So if we add all of this up, 0.33 plus 0.37, remember we get what our previous answer was right there, which is 0.70. So left over right here is going to be 1 minus 0.70, which is 0.30. Now, that will be the probability. 0.30 represents the probability that a randomly selected student is an undergraduate and they use a PC. So in this case, a probability that they're an undergraduate and use a PC. I'm going to put U and DR so you don't get confused by U. And they use a PC. Okay? That's it. So that's it for number 49. Okay, guys, we're now going to go to number 41. Let's take a look here. Students in an urban school were curious about how many children regularly eat breakfast. They conducted a survey asking, do you eat breakfast on a regular basis? All 595 students in the school responded to the survey. The resulting data are shown in the two-way table. Suppose we select a student from the school at random, define event F as getting a female student and B as getting a student who eats breakfast regularly. Find B complement. That means the probability of finding someone who is the complement of regularly eating breakfast. That means they don't regularly eat breakfast, right? Is what a complement is. So we're trying to find B complement. And remember, that means that someone that does not eat breakfast regularly. Sorry about my handwriting. So let's see here. Someone that does not eat breakfast regularly, right there. And it looks like we have our totals right there. What's going to be 295. And this was out of our total of 595. And that came out right there to 0.496. Okay. Now, it did not say to interpret this, but if you did have to interpret something like that, like this, you would say that right here we're talking about students right here in this particular urban school. So over many large samples of students in an urban school, there's about a 49.6% chance that they do not eat breakfast regularly. Part B, find probability if F and B complement interpret this value. So this one we are interpreting, right? So this is right here, F and B complement. Okay, so right here we're doing probability of female and breakfast complement. That means they're female and they do not eat breakfast. So let's take a look right here. So female is right there and no breakfast is right there, and that gives us right there 165 over 595. All right, that ends up being right here 0.277. Okay, so right here we're going to do an interpretation, right? And we're going to say, if we select a student from the school at random, the probability the student will be female and does not eat breakfast regularly is 0.277. Okay, or you could go and do that, you know, for a lot of the other interpretations, they say the actual percentage. There's about a point, you would just say there's about a 27.7% chance of selecting a student who does not eat breakfast regularly and is a female. Okay? Part C. F or B complement. All right, so wait a second right here. It looks like this is non-mutually exclusive because there are people that are female and do not eat breakfast at the same time. So that means it's not mutually exclusive, right? So probability of F or breakfast complement. Let's see here. So females, we would get that right here since this is not mutually exclusive. That means we have some, there are people who both are female and do not eat breakfast, right? So we're going to say that's a probability of F plus the probability of B complement minus the people that we count twice. Now, this is a chart, right? So it's actually, we don't really have to use the formula right here. We just look. We can just look at the chart. Female right here looks like we have a total of 275, right? And it's at a total of 595, so 275. Now right here, the people that don't eat breakfast is 295, but we don't want to count those females again, so we're just going to go and add in right there the additional 130. Okay, so that's going to give us right here 275 plus 130 is going to give us 405 over 595. And that gives us 0.681. Okay, and there we go. Okay, so that's it. So just right there, just to let you know, what did we actually include? It was female or does not eat breakfast, right? Does not eat breakfast, female. So we got everyone that's involved right there. So that's right here going to be that person, and that person. So we just added, basically we just added 130, 165, 110, all up and divided by 595. Okay, so there we go with number 41. All right, and the last one right here is number 61. Let's see here. A random sample of 415 children from England and the U.S. who completed a survey in a recent year was selected. Each student's country of origin was recorded along with the superpower they would most like to have: the ability to fly, ability to freeze time, invisibility, super strength, or telepathy, ability to read minds. The data are summarized in a two-way table. Remember, by the way, anytime you have that play button there, that means you can go to the book videos link that's on Google Classroom, and the publisher actually does their own video if you want to see theirs. All right, so for part A, suppose we select one of these students. Define events E as England, T as telepathy, and S as super strength. Find T given E. Interpret this value in context. Okay, so right here. So that, remember what we think, T given E. That means the probability of people that are from England and most want to have a superpower that's telepathy, divided by the probability that you're from England right here. Now, we don't have to use the actual probabilities because it's a chart. So we'll just get the number of people that are T and E over the number of people just from England right here. That's all we have to do. So let's see, telepathy, England is right there. So that's a 44 over England right here. So the probability that somebody is from England in total, that looks like right there, 200. So 44 over 200 is going to be is going to end up being 0.22. All right, so, and they want us to interpret this value in context. So let's see here, right? We're taking a random sample of 415 children from England and the United States who completed. So right here. So we're going to say, remember, this is the probability that the superpower you would most likely want to have is telepathy, given that you are from England. So we're going to say over many random samples of students. In this case, the students are what, from England and the U.S. who completed the survey. So we're going to say over many random samples right here, given the students that are from England, there's about a 22% chance that that student's favorite superpower is telepathy. All right, so it's kind of long right there, but basically you're just saying that over many large random samples, right, of the whole, in this case, population, right? And then we just define right here, it says, given that the student is from England, there's about a 22% chance that the student's favorite superpower is telepathy. All right, something about like that. Okay, guys, thanks a lot.